Okay, so this problem here that we have for our bell work is a problem that you will similarly see on, I believe it's page 2 of your packet, problem 9, and I'm talking about packet 13. So if you haven't done that problem, I would use this example to help you out. So with this problem here, we're going to first find the horizontal and vertical asymptote, and just like yesterday or in journal 60, what you have to do to find the horizontal asymptote is look at if you have any shifts. So this is the fraction. On the side here we have a plus 3. Anything to the side of the fraction with a plus or a minus sign would tell us a vertical shift. Now because this here is a plus 3, we are going up 3 units. So in this case, we typically start at y equals 0 for the horizontal asymptote. But because it's being added 3 or shifted up 3, we're going to go to y3. And so we have a horizontal asymptote at y equals 3, so that means that we have a range of all real numbers except when y is equal to 3, because asymptotes we can't touch. So that means that at y, we shouldn't be able to touch that value 3. As for the vertical asymptote, we look in the denominator to determine that out. So this denominator here is x minus 2. So what value here would make this denominator 0? So what x value needs to be here to make this denominator 0? Well, in this case, it would be negative 2, because x minus 2, if I were to try to make it 0, I would have to add 2 to this side here, and so x is equal to positive 2. If I said negative 2 a moment ago, I am so sorry. I meant to say positive 2. X equals positive 2, and then my domain is all real numbers except when x is equal to 2. So I'm going to say x is not equal to 2 for the domain. All right, now that we've had our asymptotes, we're going to graph them. So at x equals 2, I'm going to go ahead and make my dashed line a vertical asymptote. And then I have a horizontal asymptote at y equals 3, so I'm going to make a dashed line there. Now, if you remember from before, we used to start drawing our curves in the top right corner. Now, here's the thing. This here is a, let me just use a highlighter here. There's a negative sign here in front of this fraction. Anytime you have a negative in front of the fraction or in the numerator of the fraction, what happens is it causes the curves to switch location. So it reverses the location of the curves. And so what I mean by that, instead of starting in like the top right corner and then the bottom left corner, it's going to flip. Instead of up here, you're going to be down here in the right bottom corner. So I'm going to draw an asymptote down here. And then I'm going to draw an asymptote right here, diagonal from it. So notice how the curves went from this diagonal to this diagonal. So that's the only thing that happens when you have a negative sign. Everything else is calculated the same. Now let's move on to our next slide. Okay, so in this slide here, it's super important that you take these notes down. It's really good to help you study for the test. So these two charts here are talking about how do you find the vertical asymptote and the horizontal. Now we've been talking about how we would find them. However, the problems that we've been dealing with lately, you might have noticed that the numerator has just been a constant or just a number like 1, 2, 3, 9, whatever, but it doesn't have any x's, okay? So in this case, today we're going to deal with rational functions that have more variables in them with maybe higher powers and how to deal with that situation. The good news is that solving the vertical asymptote is not much of a difference than what we've been doing before. We're still finding x values that make the denominator 0. The only tip that I want to add here is that sometimes you might need to factor. So if you notice you can factor the denominator, then try to factor it because you might end up having more x values that causes the denominator to be 0. And I'll show you an example of what I mean here. Okay, for the horizontal asymptote, we have 3 situations that can happen, and you might notice that I have some really weird words here. And I'll talk about what these words mean. These words, bobo, bots, eats, DC, is actually an acronym that we use to help us solve the horizontal asymptote. So let's start with bobo. Bobo represents bigger on bottom 0. This O here represents this Y equals 0. So let me give you an example. So let's say that we have a rational function that looks kind of like, let's say something like this, okay? So what I mean by bigger on bottom is that I'm looking for the bigger exponent. Is it on the top? Is it on the bottom? In this case, if the bottom has the bigger exponent, whereas when I take the numerator, the biggest exponent in the numerator is x to the first power, whereas the bottom here is x to the second power. So in this case, the bottom's the winner. The bottom's bigger. So when I mean by bigger, I'm talking about exponents typically on x, or the variable, okay? So in this case, if the bottom exponent is bigger, that means that your horizontal asymptote will always be y equals 0, okay? Now the next one here, we have bots, which represents bigger on top slant. What that means is you have a situation where the exponent might be bigger on top. So let's say like x squared minus 3 over x plus 1. As you can see, the top's exponent is bigger than the bottom. So in this case, our horizontal asymptote, well, here's the thing. Slants, when you look at a graph, a slant is not flat like a horizontal asymptote is flat. Slants kind of are, well, they're slanted. And in this case, we won't have a horizontal asymptote. So there are no horizontal asymptotes, so we're going to just write none. So anytime you notice that the top exponent is bigger, then in that case there are no asymptotes. There's not going to be a horizontal asymptote. As for the last one here, eats DC means exponents are the same, divide by the coefficient. Okay, so what that means is in the situation where you have the top and bottom, the highest power in the top is also the highest power in the bottom. Well, what you have to do here, so you can see it with this case, both of the exponents here on the top and the bottom, the highest ones, are both the same, right? So what you have to do is divide by your coefficients of those exponents, or those variables. So here's what I mean. So notice that your coefficients in front of the variables is 3 and 2. So in this case, your asymptote is going to be 3 divided by 2, or 3 over 2. And there we have it. We have found the asymptote for that rational function. So whenever the exponents are the same, you're going to take the number in front of it, or the coefficient, and divide them. Okay, so now let's try doing each example of these. So I'm going to show you 3 graphing examples in the next slide. Okay, so on here, we're going to take a look at this function. And when I look at this function, I notice that, okay, the highest thing in the top is a 10. It's the only thing. And the bottom, the highest thing is an x to the first power. Now, which one is bigger, top or bottom? Well, 10 is just already just a 10, right? But x can be anything it wants because it's a variable. So in this case, x could be 100 for all we know. So what I'm saying is that when you're comparing a variable with a number, the variable is going to win. So it's going to be bigger. So in this case, our bottom is bigger. So this is the case of Bobo. When the bottom, the bigger on the bottom is 0, if you remember from our chart from before. So I'm going to label this as Bobo. So before I get into this, I'm going to try to calculate this Y-intercept. So to find a Y-intercept, that's when we plug in 0 for X and solve for Y. So if I plug in 0, let's do this to the side here. 10 over 0 plus 5, that's going to be 10 over 5. 10 divided by 5 is 2. And so we have 0, 2 for my Y-intercept. To find the vertical asymptote, we look in the denominator and figure out what X value makes this denominator 0. If you think about it, X plus 5, set it equal to 0, I would have to subtract 5. So X had to have been negative 5. So X is negative 5. And so that means our domain is all real numbers except when X is equal to negative 5. All right, so for our vertical asymptote, we just said before, we have Bobo, bigger on bottom, equals 0. So that means our Y value is going to be 0 because our bottom exponent is bigger. And so in this case, our range is going to be all real numbers except when Y equals 0. All right, we're ready to draw our asymptotes. So just like before in the last journal entry, we're going to graph by using our asymptotes first. So we have a negative 5 vertical asymptote, so I'm going to make my dashed lines. And then we have Y equals 0 as an asymptote, so I'm going to make my dashed lines. And next, I'm going to draw my curves. But hold up, you know what? I'm going to also plot this Y-intercept here. So this Y-intercept's at 0, 2. So that's right here. And that kind of gives me a little bit of an accuracy, but notice also it's in the top right corner. Also tells me that I need to draw a curve in the top right corner. And remember, when you're drawing your curves, you want to slope towards those asymptotes but not touch them. That wasn't a very good curve, but that's okay. And then the other one is going to be in the opposite direction. So in the bottom left corner. Okay, and there we have it. We have our graph and all the information filled out. So let's move on to our next example here. All right, so we have this example. Let's take a look at the function. So notice that the highest exponent in the top is x squared, and the highest exponent in the bottom is x to the first power. So which one's bigger? Well, it's going to be the top, right? The top's exponent is squared. And so in this case, this is buts. Bigger on top, slant. So we're going to get to see the slant this time on the graph. But first, let's try to calculate the Y-intercept. So Y-intercept is when I plug in 0 for X. So if I plug that in, X squared, so 0 squared minus 6, 0 plus 2, 0 squared is just still 0, minus 6 is just negative 6, 0 plus 2 is 2. If I divide, that's negative 3. So I have a negative 3 here. And so now let's calculate our vertical asymptote by looking in the denominator. So our denominator here is x plus 2. So that tells me that I have probably x equals negative 2, right? Because if I want this x plus 2 to be 0, I would have to subtract 2. This would make x equal negative 2. So in order to make this bottom 0, this x needed to be negative 2. And so our domain is going to be all real numbers except when x is equal to negative 2. As for the horizontal asymptote, we just said that this is bigger on top. So when we're bigger on top, we have a slant. And slants don't have horizontal asymptotes. And you'll see that once I graph it. But in this category, when the top is bigger, there are no or none horizontal asymptotes. So that means that the range is going to be all real numbers. Because there is no asymptote, there is no y's that cause it to be not able to touch. So in this case, all the y values are included. All right, so let's graph. I'm going to start out by drawing my vertical asymptote at negative 2. And then I'm going to also plot my y-intercept. So 0, negative 3 is right here. And because this time around, we don't have two lines. It's not as easy, right? Like when you had those two asymptotes, you could tell, oh, that's the top right-hand corner, so I probably need to start there. But this time around, there's only like this one line. So what do I do, right? Well, here's the thing. Because I notice this Y-intercept is down below and there's an asymptote, this Y-intercept needs to curve along against that. And because this point is down below in the negative region, I have a feeling that it's going to be curving down. Okay? And so if this part's curving down, if we were to extend the other side, this one's going to be curving up. And this actually will curve on up forever. Okay? It's just going to go up. And notice that it will have this slant towards it. Because there is no horizontal asymptote, there's nothing stopping this curve from pointing straight, like going diagonally up. So we have a slant. However, we still have another curve on this side. Because the domain is all real numbers, we've only covered the values between -2 to infinity. But what about this side? Because the domain exists on this side. So in that case, what I do is I think about this asymptote here. This side is pointing down. Well, that means that this side needs to be pointing up. The opposite side needs to be pointing in the opposite direction. So this is going to be pointing up. So I'm going to pretend like I'm getting really darn close to this asymptote. So then the other side needs to be kind of curving out later. Now, if this part is a little bit hard for you to grasp when it comes to drawing the curves, I want you to wait until the end of this video where I graph the curves on a graphing calculator. That's going to really help for those of you who struggle with figuring out the location of where the curves start. Please wait at the end of the video and I'll teach you how to use the graphing calculator to help you out. Alright, so this one here, when I look at this function, I notice that the top and bottom, the highest power in the top is x squared and the highest power in the bottom is x squared. So they're both the same. That means that this one is eats dc. And we'll talk about that one situation in a sec. I'm going to first find the y-intercept. So if I plug in 0, 3x squared, 0 squared minus 4. Well, 0 squared is just 0. 0 times 3 gives me 0. So my top is 0. Where the bottom, 0 squared minus 4 is still just minus 4. So if I divide, anytime 0 is in the numerator and you divide, you will get 0. Okay? So in this case, we have 0, 0 as our y-intercept. So it looks like it's at the origin. Now, when I look in the denominator here to help me find the vertical asymptote, I notice that this is a quadratic. It's x squared minus 4. So because it's a quadratic, I might want to factor this first before I set it equal to 0. Because if I factor, notice how, okay, I have two x values. What multiplies to get me -4? Well, -2 and +2. If I set both of these factors equal to 0, this one, to make this 0, would be x plus 2, right? Whereas this one here is x minus 2. So that means that I have x equals 2 and minus 2. You have two vertical asymptotes. So the domain is all real numbers, but x is not going to equal at 2 or -2. And then for my next one here, I'm going to have a horizontal asymptote. And when it says, this one here, we said that both the top and bottom are the same exponent. So in this case, eats dc, oh, I think I forgot my s. Eats means exponents are the same. dc means divide the coefficient. So this is where we take the coefficient of the top and the bottom. So this coefficient is a 1. And we divide. So if we take 3 divided by 1 for our horizontal asymptote, we're going to get 3. So in this case, our horizontal asymptote is 3. But here's the thing. Hold off on figuring out the range yet. This one's a bit tricky because this one is when the denominator and the numerator have the same exponents. So the range is a bit tricky to find. So I'm going to graph it first just to to make sure that my range is correct, because it's not as simple as before where we write all real numbers and then cross out y values that don't work. We have to interpret the graph, unfortunately. So now I'm going to draw my asymptotes here. So my asymptotes at 3, and my vertical asymptotes at -2 and +2. Okay, and I'm going to plot my y-intercept, which is at 0, 0 right here. So here's the thing. We typically start in the top right-hand corner for our curve. So I'm going to go ahead and do that and make my asymptote and get really close to those horizontal and vertical asymptote. So notice that I've covered this right-hand region. Now, if I were to go in the next section, it's right here. But my y-intercept is right here, so I now have to be working in this region. Now, if I were to make this line curve up, I am going to hit these asymptotes, which is not good because I can't cut through asymptotes. But if I curve this down, I can curve it along the asymptote and not hit it. And same thing with this slide here. So in this case, this curve is going to curve on down and against the asymptote. If I were to curve on up, I'm going to hit an asymptote, which is not good. And then, so I've covered this middle section. For this last section here, notice how this curve curves down? So that means on this side, it has to start by curving up. Well, if I start in this region, that means I'm going to be curving in this top hand corner. And there we have it. In this one here, we have 3 curves. So now let's calculate our range. So our range here is our y values. When you look at this here, notice that this is pointing down towards -infinity. So we're going from -infinity. Let's see where we're headed towards if we go back up. So -infinity, and then we hit 0 for y. But notice that there is this gaping section right here where there's no pink curve that's drawn, right? So from 0 to 3, there are no curves drawn. But here's the thing, from -infinity to 0, and this 0 here is a closed circle, we can touch 0. I'm going to put a bracket here. But after, so 3 and after, it goes up. So it's going to positive infinity. So from 3 to positive infinity, we have lines or curves. And this 3, at the 3 is an asymptote, so I need a parentheses. And then I'm going to use U for union. Okay, and there we have it. We have our range here. So notice that this one's a bit more complicated because we have to account for that gaping section right here where there's no curves. Now, I know this graph was a lot for some people here, okay? If you had a hard time graphing this and figuring out all like those little details, because there are 3 graphs here, I'm going to show you how you could do this problem using the graphing calculator. So I'm going to go grab my graphing calculator here. And I'm going to turn it on, and I'll flip the camera here in a sec. Okay, so flip my camera. I know it's on black screen right now, but just bear with me, getting things set up. Okay. All right, so on here, what you're going to do is you're typically in this mode, right? So you have to hit y equals, which is this top hand left corner. Just watch my fingers. So y equals allows you to graph, and I need that 3x squared, and it was a fraction, so what I'm going to do to get that fraction is I can hit divide instead of fractions or just division, and I'm going to enclose that or put in parentheses x squared minus 4 and close that parentheses. So I'm going to show you what it looks like on my graphing calculator. And now I'm going to hit this button here, graph, to see what it looks like. And notice that it creates the same picture as what we drew. Now, you're probably asking me, okay, why, Ms. Cheng, did you not just teach us this in the beginning? And why do we have to do this by hand? Well, the reason why is this graphing calculator does a really good job at drawing the curves, but it doesn't create those vertical and horizontal asymptotes. You can kind of see where they might be, but it's better and easier to show you how to figure that out by hand, actually. So the graphing calculator is great to figure out where might the curves be. So I highly recommend using it to double check where your curves might be. But when it comes to drawing those asymptotes, you still probably need to do that by hand. The calculator is not going to do a great job at showing you explicitly where they are. So that still utilize those skills that we've learned. All right, hopefully that helps you out. And now this is the end of the journal. I'm going to make another video here. So stay tuned for that, but it's going to be a video over page 3 of the packet, and I'm going to try to do all the problems from that packet. So if you're having trouble with page 3 of packet 12, look out for the video for graphing rational functions.